Do you remember the old design where I made this robot and then I showed you how I was using this with the Adafruit servo driver and the robot was working fine, as you can see here, but unfortunately it couldn't stand on its own. And that's why I went into this rabbit hole and decided to make my own board. In this first version it can provide up to 14 amps and I added a few headers to connect to the 5-volt servo motors. That works absolutely fine, I had no issues there, and made another board. I decided to add in a board and I went with the Teensy board, but that completely died. I don't know what happened, but it's completely gone. It's probably in a landfill somewhere. And then I also added some headers for Wi-Fi connection. And if we zoom in over here, you can see this tiny IC, and that is a power management IC that decides to either take power from the battery or the USB. In case I power them on both, it will have a priority level. Of course I did something wrong here, it didn't work. Completely scraped that, added a blob of solder, and now I decided to test the board and see how much amps I can run through it with this INA219 board from Adafruit, where you can measure the current you're running through the board. I've also added a LiPo short stop in case something goes wrong, we all make mistakes. And I'll need to order a new one because it takes ages to populate it. I'm rotating the rotary encoder that controls the servo home position and we get about 0.21 amps. There will be a stage where we run up to 0.5 amps, which is quite big for a servo board that has no load on it. Now I'm going to increase the load here to see if we can get a bit more current out of. You can see we just got up to 0.41 amps. So the next thing was to add more servo motors, of course, to see how much amps we can push through it. So I made this design Fusion 360 where I can put the PCB on top and 3 servos around it, which equates to one leg of the robot. Now, these are theoretical numbers because there's no load, but at least it will give me a baseline of how much amps are going through the board. So here I'm just adding 2 screws to the board with an M3 nut. That seems pretty secure. So now I'll add in the servos. Ideally, I would want to test it with 12 servos while it's running, but I'm sure that will not reach up to 14 amps because each leg can take 4 servos and can provide up to 14 amps. And in total, we've got 56 amps, so I doubt we'll hit those limits. So maybe in the next design, I can add in these Adafruit INA219 ICs so you can measure how much current we can push through each leg, and I'll have 4 of these since I've got 4 legs, 4 channels. So now I'm adding the servo and separate the connection where I'm supplying the PWM from the Arduino board and measuring the current from the Arduino board. Then it goes through my own PCB and I've connected all the grounds together, and then I'm using the rotary encoder to control the servo home positions. Everything seems fine, seems to work, I've got no short circuits, and I'm testing to see how much amps can go through this board without any load. It's fair to say that we might end up with using double the amount with having a load. So the measurement equates roughly to 2 amps. Now of course, this is without load. Now in the future I'll add 2 more of these encoders so I can control the X, Y, Z position of the inverse kinematics so the robot can go up and down, and that will be my walking gate. In the next video I will show you the gate and I will upload all the code designs. Let me know what you think. Like the video, didn't like it, dislike it. Any suggestions, if you found a mistake I made, put them down in the comments. And if this gets enough views, maybe I'll actually push 56 amps through it. You never know.